Now we'll practice simplifying radicals with variables. So looking at the square root of 81 times x to the fourth, the birthday cake method doesn't work as well with these. You can do it with the number, but with the variables, we kind of need to break it up and look at how many we have. So there's two ways that I like to think about this. I notice right away that 81 is a perfect square because 9 squared equals 81. So that's good news. I can rewrite this square root, kind of separating out the information I have. If I have x to the fourth, that's 4 x's being multiplied by each other. So I could also think of that as x squared times x squared. Well, the square root of x squared, those are just opposites. So that would simplify. And I can simplify each of these little pieces. So I can even break it up further and see that the square root of 8 is 9. The square root of x squared is x, and the square root of x squared is x. So my answer would be 9x squared. If you like to write it out even longer to see all the pieces, you could also break down all the pieces. So 9 times 9 to represent 81, and then we can write out all the x's that we have. So we have x to the fourth, so 4 x's. To simplify from here, we're looking for those pairs. So 9 and 9, it's a pair. Here's a pair of x's, and here's another pair of x's. So anytime we have a pair under the square root, that means we just bring out one of those things outside of the radical. So 1, 9, 1x, and 1x, which also gives us 9x squared. So you can think about it in either of these ways. If you are struggling to see where those pairs might exist, it helps to write out all of the individual pieces like this blue one. All right, and we're going to use a similar strategy for number 3 over here. This one is the cube root of 8 times g to the 6th. So this time I'll write it out first with all the terms. So 8 is a perfect cube because 2 cubed equals 8, so that's going to be helpful for me. 2 times 2 times 2, that is equal to 8. And then g to the 6th, well, that's 6 g's multiplied, so I can write out 6 g's. 2, 3, 4, 5, 6. So all of that is under my square root here. Okay, so when we did the square root, we were looking for pairs, but for cube root, we need to look for triples. Because it's a cube root, so it needs to be something multiplied by itself 3 times to simplify outside the cube root. So I see I have 3 2's. Here's a triple of 3 g's, and I have another set of 3 g's. So I can rewrite this as 2 times g, which also simplifies to 2g squared. And again, just another way you can look at that, you could instead split it up to be the cube root of 8 times g cubed and g cubed, because 3 plus 3 makes that 6 that we had. And so then if we break up each piece, well, then we see where those answers we just got come from. The cube root of 8 is 2, the cube root of g cubed is g, and the cube root of g cubed is also g. So again, we get 2g squared. All right, we also have examples where we have multiple variables. So this is the same strategies we were just doing, but there's just more than one variable, so we need to be careful we don't mix those up. So the square root of 36 times x squared times y to the 6th, I am going to write that out. 36, I should notice, is equal to 6 squared, so that's nice. We've got a perfect squared here. So I'll go ahead and write out the long way. We have 6 times 6. X squared is 2 x's. And then y to the 6th would be 6y's. Okay, so now that we've got that all written out, because we're doing the square root, we're looking for pairs. So I see a pair of 6's, a pair of x's, and I have 3 pairs of y's. So this can simplify to 6 times x times y times y times y, right? We have 1, 2, 3 pairs. So to simplify that fully, we'd write 6x, y, and 3 y's would be y cubed. So again, another way you might look at it is breaking it down to see 36 times x squared times, we can have 3 sets of y squared. So it's up to you which method you prefer. The trickiest part of these is just keeping the variables separate so you don't accidentally combine any x's and y's, because that wouldn't work out. All right, our last example here. So our last example here we might notice is got a fraction in it, they're being divided. So that's okay because we can just split it up and write the cube root in each part of the fraction. So we could write this as the cube root of 64 x to the 9th over the cube root of 343. So just like all these other problems, we're just kind of dealing with 2 different pieces in the fraction. All right, so 64 and 343. I'm gonna go over to Desmos and check out if those are perfect cubes. So again, we click the little keyboard on the bottom, functions, miscellaneous, and then you click the little N root so you can type the 3. 64 is a perfect cube. It equals 4. And 343 is also a perfect cube. It equals 7. That's good news for us. So I'm going to make a little note that 4 cubed equals 64 and 7 cubed equals 343. So we can rewrite this. I'm going to choose to break up each of the pieces that I have. So 64 I know is a perfect cube. And then I see x to the 9th. That makes 9 x's. So I'm going to split those as x to the cube, x cubed, and x cubed, all being multiplied together. Because if I combine those back, that equals x to the 9th power. But seeing it as x cubed helps me because the cube root of x cubed is just x. And then on the bottom, we know 343 is a perfect cube, so I can just write it like that. So then simplifying this, the cube root of 64 is 4. The cube root of x cubed is x. Again and again, we've got 3 sets of 3 triples of x. And then divided by 7. So our final answer is 4x cubed over 7.